Okay, great. So we have established the fact that MR is equal to MC. We've got that. The question is, as I said, we're always given MC. The question here is, what is MR? Now, let's just kind of build this a little. First of all, we're given, in the exam you're given, the relationship between price and quantity, which is the demand curve. We saw that earlier. I'll just take you back to that. Over here, this relationship of price is equal to A minus BQ is really the representation, or is depicted by this picture here, where this is price, P, is equal to A, and A is this point, the point on this curve over here, where you're selling, you can't sell anything. The price is at the point where you're selling nothing. And A minus BQ, it's minus because it's a negative sloping curve. And B is the change in price over the change in quantity. So really, it's really saying that when price, imagine price falls by a certain amount. How much does price have to fall by so that you're able to sell the next additional unit? Right, so imagine you have something like this. So basically, imagine what I'm saying here is that price falls by 50p to be able to sell the additional 1 unit. That sort of relationship. That's what B is. Change in price over quantity. So this is my price curve, but and if you like, this is this relationship over here. So I'm starting off with this relationship, the relationship between price and quantity, but I'm interested in this relationship really. I want to know marginal revenue, because it is marginal revenue that is equal to marginal cost. So I need to know what the quantity is when marginal revenue is equal to marginal cost. So I derive the marginal revenue. I find what marginal revenue is from P is equal to A minus BQ. When I say find it, we can. I mean, after all, it did come out. It was as a result of this that we found this and then this. So technically, the marginal revenue will come out of this, of this sort of relationship. Will come out from here. So the question is, what is it? So the negative, like I say, sign shows us there is a negative relationship between price and quantity. B is described as the gradient of the line, the amount the price has to change the demand by 1 unit. This is the gradient, the change in price divided by the change in quantity. So we establish the price and quantity relationship, and then we are also given in the exam the marginal revenue relationship, and MR is equal to A minus 2BQ. So P is equal to A minus BQ, and we're literally doubling the gradient. It's telling us that MR is equal to A minus 2BQ. So this is marginal revenue. Right, now what does this mean for us? What does this mean for us? How do we use this? Oops, sorry. How do we use this information? So now we know what marginal cost is. We will be given this, simply the variable cost per unit. And again, like I said, because we will be told what marginal cost is, we literally, if we know that at optimal point MR is equal to MC, so if we know that if we're given A minus 2BQ, we know this must be equal to marginal cost. And so ultimately we now have an equation that we can solve to find this quantity, because that's ultimately what we're looking for. Now here's the thing, I can find A and B. I need to find A and B, but I need to find A and B from my price curve. So my price curve, which is A minus BQ, P is always equal to A minus BQ. So that I'll have 2 points on here where I'll know where I can use, which I can use, right, to find my A and B. So ultimately, the technique is that I need to find, my first task is to find A and B from my price curves. And then when I found A and B from my price curves, I literally take them and come back in here and then apply it. Right, and so that's kind of and they can ask you other questions as to what to calculate the maximum profit. It doesn't really matter. The key point here is that once I found the optimal quantity, then I can go back and plot that and plug that into the A minus BQ, because by putting Q here, then I can find the price what I should be selling it for, and then I can, of course, whatever, I know what the costs are and I can deduct those. But but let's just sort of see an example. So here it tells us, we're looking at the relationship here between price and quantity, and this is what I'm given. I'm given the selling price, that when I'm selling, when I'm able to sell when I set the selling price at £300, we can sell 500 units, or if we set the selling price at 330, we can sell 400 units. So what I'm going to first of all do is just show you, so just sort of, I'll do it here because I can keep rubbing out, it doesn't really matter. What I'm telling you here is, this is what my demand curve looks like. So when I'm selling 400 units, it's at £330. I sell each of them at £330. Or when we sell 500 units, it falls to £300. So we have a curve that looks like that. So the truth is, if I have this information, I can find other points on the curve. So I mean, there's an A and there's a slope, right? There's a slope that the question is that every time, to sell an extra unit, I have to drop price by a certain amount, and those figures are the A and the B. So the question is, I have 2 points on a curve, and I can find any other point ultimately. But I actually want to find A and B. I want to understand what the nature of this relationship is. I want to know what A is. So if I was to write my equation out, I would write something that looks like this. I would write P is equal to A minus B Q. So Q, right here, I'll write the first, so, oops, let me start again. P, which is, I'll take this first one, 300 is equal to A minus 500 B, right? Because that's the price. Then I also have 330 is equal to A minus 400 B. So the question is, I can now find A and B easily. Well, all I will do here, actually I'll write this the other way, well, it doesn't really matter. Key point here is that I'm going to find B first, because these A's will cancel out, if you remember your simultaneous equations. So I'm going to go, I suppose I should have said 330. I'm going to take this equation from this. So this is equation 2, and this is equation 1. So I'm going to take equation 2 from equation 1. So I'm going to say, I'm going to write it the other way around, just because I prefer it that way. You could do it the other way. It's just the maths of it. It's just, you just have to don't miss out your pluses and minuses. So if I do this, so 330 minus 300 is 30. A minus A is equal to 0. So minus 400 minus 500, technically, because this is a minus 500. This is minus 400. Technically, this is minus 400 plus 500, because minus 400 minus 500 turns this into a plus. So really, it's 100. 100B. So 30 is equal to 100B, and therefore B is equal to 30 over 100, so B is equal to 0.3. So 0.3. So I have to drop price by 30p in order to sell an additional unit. That's what this is saying. So now I know B. Well, now that I know B, I can find A. So I can go 300 is equal to A minus 500 times 0.3, right? Because B is 0.3. So that means that 300 is equal to A minus, this is 150, because 3 times 500 times 0.3 is 150. And if that means that A is equal to 450. So now I know what A is, and I know what B is. So the equation of this curve is P is equal to 450 minus 0.3 Q. So it means that for any Q, if I'm asked about whatever 450 units or 200 units, all I have to do is plug that in, and I can know what price I should sell for according to this curve. That's the first step. Right, great. So I'm just going to, P is equal to 4, I mean this is recorded, so you can, P is equal to 450, P is equal to 450 minus 0.3q. So now I know this. So like what I was saying earlier on, the next step moving on is now this question of marginal revenue. If this is my normal curve, my marginal revenue curve is 450 minus 2 times this, which is 0.6q. This is given to you in the exam. P is equal to A minus BQ, MR is equal to A minus 2BQ. So I now have this. So the question becomes, well, I'm told that using the price equation, assume the variable cost is 90, calculate the optimal price and quantity. Well, if MR is equal to MC at optimal point, that means that 90 is equal to 450 minus 0.6q, right? Because this is MR. MR is equal to MC, so I just substitute MR for MC. And now I can find Q, right? Because it means that Q is 0.6Q is equal to 450 minus 90. So 0.6Q is equal to, this is 0, 15 minus 9 is 6, 360. And that means that Q is equal to 360 divided by 0.6. Right, and so 6, and that's equal to 600, isn't it? Yes, because so you have Q is equal, well, you could say 3606, and that's is equal to 600. So it's telling you that the optimal point to sell at is where Q is equal to 600 units. It's telling you after that stop. So what does that mean? I now know what Q is. I know Q is equal to 600. And if I know what Q is, that Q is equal to 600, that's the optimal output. What is the optimal price? Well, I know I have my equation up here. The optimal price must be P is equal to 450 minus 0.3 times 600. And 0.3 times 600 here is, we have 180, right? P is equal to 450 minus 180. 0.3 times 600 is 180. So P is equal to 450 minus 180, and that is equal to 0, 15 minus 8 is 7. And then you have 2. So P is equal to 270. That's my optimal price and my optimal output. Right, good. And then finally, it talks about what is the maximum contribution. Well, ultimately, really, what we're really saying here is that we know that the variable cost is 90. So, I mean, if you're selling at 270 and the variable cost is 90, well, if you like, well, I'll just find the contribution for each one, which is 0, and then 17 minus 9 is 8. So you have 180 on each unit, and you're selling 600 units. So calculate 180 times 600, and you arrive at your maximum contribution. Cool. Great. And if the question had asked for profit, you would do this first and then subtract whatever the fixed costs were. Cool. I'll end the video there because that's been quite big. But that's the key point. I hope I've been able to fully explain your key tasks, which is ultimately you would first of all find. This is another example, and you can practice this. But the key point here is your ultimate task is to first of all find your equation of P is equal to A minus BQ by kind of mapping out this, picking these 2 points. And then this is another example, so please do this. You have 2 points and then finding P minus equal. Then once you found A and B, you can then say, well, you're confident now, A minus 2BQ. And then you'll always be given, you'll always be given the variable cost. Here they just want you to do a bit more and just to predict 300, which is fine. Once you have your equation, you can just plug in to find out what's going on at 300, and that's fine. And then you're given this is the big one, where you're trying to find out what's happening here, what's the optimal point, and when MC is equal to 100, and that's definitely when MR is also equal to 100. So 100 is equal to A minus 2BQ, you would have found B and A, and you just substitute to find Q. And then you find the maximum contribution like we did in the last question. Okay, that was a long video, 15 minutes. I think I'll stop there. See you in the next video.